Hello and welcome. In this continuation of our Learn to Code series, we will make a game slightly more complex than our first, which came in at a whopping 60 lines of code. This game will also be more familiar to many, so let's begin. Episode 1 recap. I teach how to think in code. You must learn how to do the coding. People who know how to code know how to translate requirements into instructions, something we will practice yet again shortly. This game is going to be a minimal reproduction of the popular match-to-memory type in casual gaming. If you aren't familiar with match-to-memory games by name, I am almost positive you will remember based on a visual example. You start out with a grid of squares, typically showing some sort of uniform design on the back of each square. You select one square, which reveals a picture or animation of some sort. And the idea is you will choose another square at random, hoping to find an image that matches the previous one you just flipped. If you find a match, those squares remain flipped and you have progressed the game. If you did not find a match, both squares flip back over and you must start the guessing process over again, ideally keeping a mental note of the pictures and positions you have already revealed in previous attempts. This process repeats until you have successfully matched all the pairs of images. A score may be kept track of how many attempts you required to complete the game. So, are you ready to recreate this classic yourself while you practice coding along the way? Let's discuss our requirements in plain English, and then we will identify the patterns we learned from episode 1 and how they might apply in this example. Now remember, identifying those patterns is key, so one can translate the human language into computer language. So I need to represent my squares in a sequence. Let's say 10 unique images. So total of 20, 2 of each kind. I need to randomize the order of my squares so you can't expect where to find a given pair. If they're all in order, it's going to be very easy to beat the game. No fun. I need to be able to visually represent my squares in a grid. Since we have a total of 20, let's use a 5x4 grid. In the beginning, the player will not know which images are where, so we will display a square with the same image backing. We'll need to accept user input in the form of clicking on a square, which will trigger our guessing/matching logic. Each guess will flip a square, show its image. If it matches a previous image, they remain flipped. If not, they revert back to show the backing. We'll need to keep track of the number of guesses, which will be the number of square flips divided by 2, since a guess is made up of checking 2 locations. Okay, plain English, functional summary here. I'm not going to read all that, but you can pause the video and use that as a reference. We're now going to investigate the patterns in these requirements. And again, the patterns themselves are discussed in detail in episode 1. Go ahead and check that out if you haven't. But take a look at the bold in some of these. It's kind of an overlay of information based on those requirements again. So you're going to see things like on the first one, using an array. On the second one, using some sort of algorithm function for that randomization. And then just moving down, again, reviewing those bold kind of patterns, those are going to reference directly those patterns that we have discussed in the past. Now, again, just to reiterate, this is key. The more you do this over time, the better of a coder and designer you're going to be in breaking down something into what you can write down yourself, what you want this thing to do, and then be able to translate that to functional requirements that can be actioned by a developer. Pause the video if you need to, read through some of this stuff, and when you're ready, just go ahead and hit play and we're going to continue on. I'm going to do a recap of my solution. So it had a whopping 3 whole lines of HTML. This one, 83 lines of JavaScript. Remember that episode 1's project was 60 lines, so a little bit more here. Let's see, I used a clever way of getting the illusion of images without actually using images, which can be heavy. I used UTF characters. So if you don't know what that is, do an internet search, and you're going to see that in my implementation source code. So I also used 5 functions. They're kind of summarized there, and then 9 variables. I said global scope. If you don't know what that means, check out, again, episode 1 there where it talks about scope. If you are familiar, they're just top-level kind of variables that can be referenced and changed from anywhere. Let's cover some new concepts since episode 1, the guessing train. So in this project, different from that one, I used UTF characters, which I mentioned. So if you don't know what those are, they're really fun and accessible in any browser for projects. So definitely check that out. I needed a way to wait a little in between guessing so that everything wasn't super quick. JavaScript has this lovely built-in function called setInterval. which allows you to run logic on a delay. I also used modulo, mathematical operation. So that one seems scary. Just do some research. It's a standard math operation, just like multiplying, dividing, but it's super useful in doing like remainders. And that is, in my case, I used it to do something every certain amount of times. So in this case, when I was building out my grid, I started a new row every 4 images so that I could do that 4x5 grid. We're loading our JavaScript from a separate file this time in this project, which is nice. It's better, it's clearer, and just better organization of the types of files involved. Bonus topic, so application state. This is going to be a big one in anything you ever create, from applications to games to literally whatever. This concept of state, which refers to data stored in computer memory running in that program. So variables that you create, those create state, hold references to data. And functions can change or set variables at runtime, and this means they are changing the state of the application. So there's two main ways you can really reset the state. You can actually close a program all the way down and then reopen the program, and you've just reset its state, right? It's loading fresh. But that's not ideal. You don't want someone to have to close the program every time just to like start a new game or go to the home menu of an application or whatever. So you can actually modify your variables and reset them to some initial starting value, effectively resetting the state without having to close and reopen applications. So see my reset button logic? It's doing exactly that, where it's just resetting a bunch of variables to starting values so that it mocks this feel of restarting a brand new game. All right, that is all we had for this episode 2. I'm calling it primary training, so I hope you enjoy. Definitely just review some of the concepts there, try to build it out yourself, and then go to my source code for reference. All right, I got to show you the game. So here it is, match to memory game. Reset button in the bottom left there. So my backing I chose was this lock kind of emoji image there. You can use whatever you want. Let's make a guess. So I got my shooting star there and a little black pepper. Hot dog, volcano, rainbow, mushroom, black pepper. I remember where that was. Volcano, where was that? Rainbow? No. Hot dog. Oh my gosh, my memory is terrible. So working my way through some of these images here. Ooh, tidal wave. The ones I picked, I totally picked at random for the most part. You can pick whatever ones you want. There are so many. Have fun with it. I did. So I'm just working through my guesses here. If your memory's better than mine, you're probably like, oh my gosh, what is he doing? Yeah, but it's all fun. The goal is to obviously get as many matches solved in the shortest amount of time, or the shortest number of guesses. So the better your memory, theoretically, the better score you get. I just won in 23 turns. So thank you guys for watching, and I'll show you my reset button real quick. That'll just reset it without me having to refresh my whole page here. Boom. All right, guys, enjoy.